Hey guys, how's everything going? This is JSer, who is not good at algorithms. I'm making these videos to prepare my future interview. In this video, I'm going to take a look at 1029 two-city scheduling. Okay, there are two N people, and the company is planning to interview. The cost of flying either person to A is the first number. The cost of flying either person to city B is the second number, right? Okay, this one. So for the first one, if you go to A, it will cost 10, go to B, cost 20. The second one, go to A, cost 30, go to B, cost 20, 200. And then how can we return a minimum cost? So fly half to A and half to B. Well, so the general case to consider this problem is that if the cost is the same, all 10, then we don't need to do anything, just right. We just random pick 10, half of people, and it's done. So the cost, the more the cost close to each other, the less meaningful the separating will be, right? So if we say, okay, if you take a look at these people, that the cost go to A is much smaller than B, much smaller. So actually he or she is very important in determining the minimum cost. So of course, he or she must be go to A, right? To drag the cost down. The same for this guy. He or she must go to B because the deviation is so big, right? So this reminds us actually we could determine who determine the people who go to A or go to B by checking their difference, right? The more the more costly, if he costs much more than the others to go to B, then must go to A, right? So the other way to kind of think of this thing is that let's suppose all people go to A first, right? They first go to A. Now actually we need to pick half of the people to go to B, right? So how do we choose? Well, if for people A, set these people from A to B, it will drag down the cost. No, it will actually plus 10, right? Because originally it cost 10, now it costs 20. So this one, the difference changing these people's path destination would cost us extra 10. And here, of course, cost extra 170. This one minus 350. Well, so we could choose the top the smallest difference with possible negative numbers with top n people, and that is the target, right? So then we could actually get the sum of the cost, right? So the idea becomes a little clear that we sum all up to A, right? And then sort the people with cost 1 minus cost 0 difference, ascending, and pick the top n people, update cost, right? So it's done. So let's do that. Okay, we first use a cost to as the return. It's initialized to 0, and now what do? We will sum up all the costs with A, right? Yeah, and maybe I think we need to use. We could just sort this together. Just sort this. Yeah, let's just sort with the origin this one. I thought that maybe you could create a new array and push the difference in there, new array and sort that array. I think it's useless. So let's just sort A and B. We will get the minimum of the difference, right? So return difference. It means this difference is A1 minus A0, right? This should be subtracted with B 1 minus b 0. So this actually will sort these array with the order of difference with b to a, with the ascending order. Okay. Now what we do, we just loop through the class, right? We now get the top n people, which would be set to b. So for let I equals 0, I smaller than costs dominant, right? Now for the top n, we use cost b, right? So cost plus equals I. If I is smaller than cost length divided by 2, the length is guaranteed to be even. So if it's smaller than it, then it should be use costs I 1, right? If the other costs I 0. Cool. And then we can return the cost. Yeah, it's done. Cool. Submit. Oh, I did this 1 year ago, man. Well, accepted, and it's pretty straightforward. Let's try to analyze the time complexity, the sort here. Suppose there's a n, 2n people, right? So here is O2n log 2n, right? So yeah, so it's O log n. Yeah, no, log 2n is actually plus, right? Log 2n is log 2n plus. Wow, so it's actually, I think this is right. And then we use log, O2n. Well, it's O log n, so this is a time complexity. But actually, I think we can improve a little bit, right? The thing is that actually for this specific question, we don't need to sort them all. You see, we only need to get the top n. For this kind of thing, for these cases that we actually like it to be some kind of sorted, but not all of them need to be sorted. We could use priority queue, remember? Yeah, the problem here, for this, we sort all the things, right? But we only need half of them. So this is a problem. We don't need them all. Well, this is about priority queue. Priority queue is very helpful for questions like top K problems. So let's try to use it. And okay. Bam! This is the priority queue. Okay. If you're interested, please search on my channel. There's a detailed explanation in how to implement the priority queue in JavaScript. Please search on that. And I'll skip this part. And in real interview, you don't need to implement the priority queue because for Java, they have built-in priority queue. For JavaScript, there is no. So all you need to do is to tell the interviewers, say, okay, I suppose there's priority queue. I'll use it directly. Okay, so then here. So here, I'll create a priority queue. Priority queue. Wait a minute. Does this work? For priority queue, we're getting the top, right? And then we get the Okay, yeah. So let's first calculate that cost to all a. Okay, for that I equals 0. Okay, that mean equals cost is 0, and for that cost of costs, mean cost plus cost 0. Now this is all the costs this is the cost when all people are set to A. Now we use a priority queue to track the n people that should be set to B, right? Cool. What we do, yeah, we create a priority queue, which we use this one, priority queue. which will keep the minimum. So the biggest one, the larger numbers will be closer to the root. We say to A, B, what we're gonna do. But this is the cost. So yeah, we just say return A1 minus A0. This is the difference, and this should be bigger, right? Bigger than the B. Bigger than. No, wait a minute. It should be bigger than B to put it to be closer, right? So it's not ascending; it's descending. Use B1, B0, divide, subtracted with A. So when this is bigger, then it actually will be put when it is plus 1. Wait a minute. Wait a second. This is confusing. This is the difference. If it is a positive, it means it has a small. It will be positive, so you should be removed first, right? So it must be closer to the origin. Okay, yeah, I made a mistake. It actually should be like this. One more time. A has the smaller. Wait a minute. If A, this means if this is smaller, this should be put closer to the origin. So if it's smaller, close to the origin, no. It's wrong. If it is closer, it should be further from the origin because it's gonna be removed. This is right. Okay, now we have PQ. Now do what? We just push them into the priority queue. Add cost. Okay. Now, if PQ size, you get the size. This is okay. This size. If the size is bigger than costs, then divide by 2. What we do? We will pull, right? We move the one. We pull one out. Yeah, and after this is done, we will have exactly n people in our priority queue, which should be set to destination B, right? And so now what we do what? We will move them to B by updating the min cost. Okay, so while PQ size is bigger than 0, let's say cost, okay, to B, okay, to A, okay, to A, to B, equals PQ poll, and then min cost should be equals to B minus 2A, right? This is the difference that moving, setting these people to B. Well, this is the cost that will be dragged down by moving these people to B, right? And then we can remove return min cost. So is this clear? We first get all the cost by setting all of them to A, create a priority queue, traverse through it, and keep track of the top n people, and then we get the n people, update the min cost. So pretty straightforward, right? We get the one new. I forgot the new. Man, sorry. Not a number. What? Wait a minute. Min cost should be right. Right, PQ is not right. PQ min cost. Right queue, this is right. So here's the problem. We pull, we get the cost, we say to A, to B, and cost. The problem is here. Well, this is right actually. This is to A, to B. to A to B to A to B, y 2 times. Cost. Oh, what? Wait a minute, man. There's something wrong here. Ah, at costs. Shit. Man. Hurt. Okay, we're good. Submit. Okay, we're accepted. Though it looks like it's more slower, but let's first analyze our time complexity. Here, you're constructing. Here it doesn't cost any time because the priority queue is initialized to empty. Here it will cost us on, and here, of course, on. But for each one we add, it will cost us this O2n, right? 2n. This is 2n. Oh, this is we used 2n before. I remove. I just clear the input. The previous solution. Wait a second. I'll just restore it by command. I'm stupid. I don't need to do that. I just click the. Wait a second. Let me finish this one. Okay, this one is 2n. We add. Well, it actually cost us the maximum is n, right? So n log n. This is the same, log n. So this is still n log n. So generally for all, this should be n log n, right? Yeah, this is 2n log n actually. So it's 3n log n. I'll just, if you write it with more details, it should be 2n plus, this is 2n log n, and plus this n, plus n log n. This should be, yeah, O n log n. Would it be better than the previous solution? Here, what we did here is that we sort, right? This is actually, I just copy this solution and put it here. It should be, this one is sort first. Here, it's O2n log 2n, right? And here is O2n. You see, the time should be O2n plus 2n log 2n. While comparing to our new solution, this is 2n plus 2n log 3n log n. This is this is actually better. Looks better. Well, looks better because you see the case here actually top half of the elements, right? N, 2n. So actually they are proportional. It's not something like top 2 among like 100,000 elements, right? It's actually top half. So the time complexity doesn't change that much. But I think if you talk to interviewers about the priority queue, and I think he will be pleased about this. Okay, so that's all for this one. This is another problem that we use priority queue. Please search on my channel if you want to know the details about implemented in JavaScript. Yeah, there's a video about that. Okay, hope it helps. See you next time. Bye bye.